Welcome back. Today in this session, let us discuss about another important algorithm based on divide and conquer strategy, merge sort. To review the previous concept of divide and conquer strategy. So divide and conquer is an algorithm strategy which suggests splitting the given problem into k subproblems. Each subproblem is solved independently, and finally we merge the solutions to those k subproblems to find the solution to the original problem. In fact, divide and conquer strategy suggests that the subproblems are all of the same kind of the original problem. So we use the control abstraction to define the flow of divide and conquer strategy. Actually, by control abstraction, we mean that the flow of operations are clearly defined, but the actual implementation of the procedure is left undefined. Say, for example, just to review what we discussed in the last class. So, control abstraction is the process whose flow it's a procedure whose flow of control is clear, but whose primary operations are specified by other procedure which are left undefined. So in order to define the control abstraction of divide and conquer, we'll be using small of p. It's a Boolean valid function that determines whether the input size is small enough so that we get a direct solution. Finally, combines the subsolutions to form the solution to the original problem P. So we also, this is the control abstraction. If small of P, then return S of P. So if the problem is small enough to get a direct solution, then return the direct solution. Otherwise, divide the problem P into smaller instances, say k subproblems. Apply the divide and conquer strategy to the individual subproblems. Finally, combine the solutions. So based on the divide and conquer strategy, we discussed binary search, one of the important search algorithms used in data structures. So binary search, it follows the divide and conquer approach. So binary search, it requires the given set of elements to be sorted. So that is an important requirement for applying binary search. So we need to find the mid element, compare the search element with the mid element based on the outcome. Suppose if the search element is less than the mid element, then the search space will be reduced to the first half. Otherwise, the search will continue in the second half. In the last session, we discussed the algorithm for implementing recursive binary search as well as iterative binary search. So today, let us discuss one more another important algorithm based on divide and conquer. So it is a sorting algorithm where we apply divide and conquer strategy, and the time complexity is reduced much. Approximately the time complexity of the merge sort will be big O of n log n. So here, the given a sequence of n elements, merge sort will try to divide the given set of n elements into two equal size subsets. So again, this process continues. So the subarrays, the two equal size subarrays are further divided. So this subdivision goes on until the subarrays has only one element. Once the problem is reduced to a simple problem means the array has only one element, then merging is done, merging is carried out. So that's how, see in this case, you can see the algorithm for merge sort. We have two parameters, low and high. So small of p. So when you are solving a problem using divide and conquer strategy, first you need to identify the small of p. So when does the problem return a direct solution? What is the size of the problem, right? So small of p should be clearly defined before applying divide and conquer strategy. So small of p is true if there is only one element to sort. So to start with, we just check if low is less than high. If low is less than high, that means there is more than one element. In that case, we divide the problem into subproblems. In this case, we divide the given array into two subarrays. So how to divide the given array into two subarrays? You need to compute the midpoint. So mid is equal to low plus high divided by 2. And then we get two equal sized arrays. So we recursively apply the merge sort to these two subarrays. So the size of the range of the first subarray will be low comma mid. The range of the second array will be from mid plus 1 comma high. So we assume A as a global array. The arrays are defined by the low and high variables. So low defines the first element in the subarray, high second parameter denotes the last element in the subarray. So the basic idea of merge sort is divide the given array, input array, into two equal sized subarrays. Recursively divide the subarrays until each subarray has one element, only one element. Finally, combine the solutions. So the algorithm is very simple. So merge process plays an important role in merge sort. So subdivision, after division, after dividing the given array into subarrays until the subarray has one element, the next process is combining. So here we define three variables, h, I and j. H and I points to low and j is equal to mid plus 1. So j points to the first element in the second subarray. Now we are going to merge two subarrays. So while h is less than or equal to mid and j is less than or equal to high, because the size, the upper value of the first subarray is mid and then the upper value for the second subarray is high. So until we compare the first element in the first array and the first element, we compare the first elements in the first and second subarray. So if a of h is less than or equal to a of j, then b of I is equal to a of h is equal to h plus 1. So if the first element in the first subarray is less than or equal to the first element in the second subarray, then the smallest element will be copied to a third array. So we use one auxiliary array to store the sorted elements. So here in this algorithm we use array B. Otherwise the smallest element, if a of h is less than or equal to a of j, then the smallest element is in the first subarray. In case if the condition is not true, it implies the smallest element in the second subarray. So the smallest element from the second subarray is copied to B. And we increment the counter, I is equal to I plus 1, and then we move on. Likewise, we compare all the elements from the subarray, two subarrays. Finally, when the first subarray exceeds its size, exceeds its upper limit, then the remaining elements from the second subarray will be copied onto the result array B. Otherwise, the remaining elements from the first subarray will be copied onto the result array. At last, we want to have the sorted elements in the original array A itself. So all the elements from the temporary array B will be copied to A. So the algorithm is easy to follow the logic. So here we use two pointers to trace the first subarray and the second subarray. The elements in the first and second subarray are compared. So to start with, the first element in the first subarray and the first element in the second subarray will be compared, whichever is larger. So if the larger element is in the second subarray, then it is copied to the resultant array. Increment the counter for the second subarray. Otherwise, copy the element from the first subarray. Here you could see there are 7 elements in the input array. If we divide into equal halves, so we further subdivide. So the first subarray will be 42, 10 and 4. Second subarray will be 1, 19 and 7. Again, the subarray is further divided into 2 subarrays, each having 2 elements, and then each subarray having 2 elements are further subdivided so that they have 1 element each. Let us see 40 and 2. So these are 2 subarrays, each having only 1 element. Now in order to merge, we need to compare 40 and 2. So here you could see 40 is larger than 40 is greater than 2. So the smallest element from the second subarray 2 is copied to the resultant array. And then the 40 is brought as a second element. Now let us see the last process. So the first subarray has 2, 4, 10 and 40. And second subarray has 1, 7 and 19. Now in order to merge these 2 subarrays, we compare the first element in the first subarray, say 2, and the first element in the second subarray 1. So when you compare 2 and 1, 1 is smaller than 2, so you copy 1 to the resultant array. 1 is copied down. Now you increment the counter in the second subarray, so now the pointer moves to 7. Now compare 2 and 7. In this case 2 is less than 7, so the smallest element 2 is brought to the resultant subarray. Here now the pointer is moved to 4. Now compare 4 and 7. 4 is smaller, so 4 is brought down, and the counter is incremented to 10. Now compare 10 and 7. Here 10 is greater than 7, so 7 is smaller. So brings 7 to the resultant array and increment the pointer to the next element, now 19. So here compare 10 and 19, 10 is smaller, 10 is brought down, increment the counter. So now the pointer in the first subarray points to 40. Compare 40 and 19. So in this case 19 is smaller, so bring 19 to the resultant array. Now there are no more elements left in the second subarray, so we need to copy the remaining elements from the subarray, first subarray to the resultant array. So 40 is copied down. So this is how merging is done. Hope you understand how merge sort works. So this merge sort, if you look at when you calculate the time complexity, actually the time complexity of merge sort is described by the recurrence relation T of n is equal to A. When n is equal to 1, it is a constant, otherwise it is divided into 2 equal subproblems. So if the n is the number of elements in the input array, it will be dividing into 2. So it 2 times T of n by 2 plus Cn. Here Cn is the time taken for merging the solutions. So 2 into T of n by 2 gives you the time complexity for dividing each array into subarrays, and C of n is for merging the time taken for merging the solutions. So when you apply the substitution method, so 2t T of n will be equal to 2 into T of n by 2. If you further expand T of n by 2, it is replaced by 2T of n by 4 plus Cn divided by 2 plus Cn. So when you substitute successively, finally you arrive at An plus Cn log n. So by expressing the time complexity using asymptotic notation, the time complexity of merge sort will be equal to big O of n log n. So this is very this comparatively better when compared to the time complexity of other algorithms, say bubble sort, it will be big O of n. So in this session we discussed about merge sort, another important sorting algorithm where we apply divide and conquer. So the basic idea is to divide the given array into subarrays So we divide continuously until we have the subarray with one element. So the subdivision stops here, and then finally we start merging. So we start merging two subarrays, and finally we get the sorted array for the original input. Thank you for listening. Let us continue our discussion in the next class.